Welcome to my channel Skill Tone. How are you, my dear learners? In this video tutorial we are going to discuss about time series analysis, its components and model, and a demonstration using our software. So without further delay, let's get started. In this video tutorial we are going to discuss about time series analysis, its component, and also its different type of models. Usually in time series analysis, it is very important in econometrics, data science or data analyst, and in future we are going to use this topic in our machine learning concept as well. But let's first start with the very basic concept. What is time series? Time series is a single variable. How it change over time we observe through this time series analysis. For instance, if we consider a country, let's say Bangladesh, and we are talking about its unemployment rate, and we would like to see how this unemployment rate varying over 10 years time period. So this variable name unemployment rate, and we are talking about a time series of 10 years to see how the unemployment rate varies over time. I mean the changes, ups and downs, and what are the different types of factors that is related to the unemployment rate analysis. So here in this case we are discussing about the component of time series analysis. TS stands for time series. So what are the components of time series? Usually in time series we have three components. One component is called the trend analysis or trend, and then we have seasonality, and finally we have cycle, or we can also say the error term. So these three components are very important in time series analysis. Let's have an example. For example, if we have an unemployment rate and it has an upper trend and then it fall down after some period of time, and we have unemployment rate and we have time in this particular dimensions, and then we would like to see over the time period it has growing up and then it going down. So these upward sloping straight line or downward sloping straight line is called the trend. So in any time series analysis, understanding the trend is very important. Then again we have to understand what is the seasonality. Seasonality meaning that the seasonal variation. For instance, in one of the year where unemployment rate may occur higher than the other time of the year. For instance, after the harvesting there might be an unemployment problem in Bangladesh in autumn season. I mean during the before the winter starts. At that time the unemployment rate is little bit of higher in the rural area. So it is because of the seasonal variation which causes the unemployment rate little bit of higher at that time period. So seasonality has an impact on time series analysis. And then we have the error term, or in other words we can call the cycle. Cycle meaning that in any economy we have a business cycle. For instance, the cycle can go up and down like this way, and this also comes with the time period or time dimension way. For instance, we can have a peak period, or we can have a drought period, or we can have a recession, and deep recession leads to depression. So seasonality, trend, cycle, these are all very important components of time series. So these components we would like to see how we can decompose those trend, I mean the components, so that we can have a very filterized data that can tell you the true story of your time series analysis. So understanding the trends, understanding the seasonality, and also the cycle is very important. At the same time we need to know how we can decompose those things in order to get the real picture of the data. And we can use many sort of way. We can have a moving average, time series analysis which can remove your trend, cyclic and seasonality problem, moving average model, or moving average analysis. Then we have Box-Cox transformation, which I will demonstrate using eViews or R in the next tutorial. And then we have our own, you can say, by looking at the data by plotting it using the scatter plot diagram. So those are the things that we can see and decompose our analysis, and the components, and then we can get a fairly filterize dataset. Now, another important point of time series is stationary. Stationary meaning that it has a constant average mean over the time period. I will discuss about that in the next slide. And then we have a co-integration analysis, which is also a multivariate time series analysis component. And we have our different type of model like autoregressive, and then we have ARIMA, autoregressive integrated moving average model, and also the VAR model. Okay, so these are the models, these are the components, and what we can do with the component I already explained. Now let's move on to the next slide. In this slide we are seeing that each data point in time series will have either a product or sum of three components: seasonality, trend, and error. What does it mean? It means that, for example, we have a time series model and it has a, for example, let's assume that there are three types of component, and the first component we are discussing about the trend. So we have trend, plus we have seasonality, plus we have error term, I mean the error in the time series. So in the time series it can be additive model, I mean combination of trend, seasonality, and error together, additive model, or it can be a multiplicable model. For example, time series is equal to something like this. Okay, so either this or that additive or multi-query model is important for time series analysis. So in order to see how the components are distributed before you start any analysis, it is very important for a data analyst. So we need to understand a time series starts with three components, and these components can be combined either by multiplication like this way, or an additive or addition like this way. So both these things can be removed by using different types of model, for instance moving average, in order to get a filterized and clean data to understand what the actual data telling about. Another important criteria in time series is called the stationary. So my dear learners, first you start with the components, and then you need to see whether your time series has stationary or non-stationary problem. So what is stationary? A time series is said to be a stationary if it holds the mean value of a time series is constant over time. I mean, if you have a chunk of pi, for instance, okay, and every chunk, if you take any chunk from this pi, will have a constant mean value over time. If it changes, I mean this chunk has given you a different type of mean value than this chunk, then you have something called a non-stationary problem. So in order to find a solid time series or a smoothing time series, you need to convert your non-stationary value into stationary. And how can we do that? By simply doing the unit root test, or in other words, or simply way, by differentiating taking first difference or second difference, you can convert your non-stationary value into stationary value. The variance does not, and the second point is the variance does not change over time. And the third point is the seasonality effect is minimal. So it has over time mean constant, variance does not change over time, and seasonality effect is minimal. So here you can see seasonality does not impact the model, and the variance is constant, and the mean value over time, variance does not change over time, and of course the mean value is constant over time. If it holds these three characteristics, then we only can see your time series has a smooth going for analysis. Now, what are the models that we usually use in time series analysis? We use simple moving average. Now, my dear learners, if you see in any moving average, for instance, there is a formula called 2k plus 1 is equal to m. So if we are interested to take a 5 years moving average, then we can use this formula to get a 5 years moving average. But it depends on what is your k. Here I am putting k in 2. You can put anything and then you can find how many years you'd like to take as a moving average. In simple terms, what is moving average? For instance, you have a data series, let's say unemployment rate. Over the time, it has, let's say, 1, 2, 3, 4, 5, 6, 7, 8 observations. So now every 5 observations, if you take their average and then put into this point, I mean here k means the number 2 observations in here, then it is says the 5 years moving average. You are taking 5 data points of that particular time series, taking their average of the values and then putting that value in the particular place where here in this case number 2, leaving the first part blank, is the 5 years moving average, and we usually use this formula. So moving average is a very easy way to remove your trend, seasonality and cyclic problem. Sometimes it is important to see what is your data tells about. So not necessarily every time you use seasonality, removing trend and cyclic variations, not every time you have to do it, but you need to see first what is your data telling about. Now depending on the data telling about, we can go to the next model called the autoregressive model or AR model. AR model is a very simple way of seeing the past value. For instance, this value, how it affects to the current value of your time series. As you know, time series has sometimes the past value affects your current value. For instance, if you have a very good GDP growth and it doesn't come all on a sudden, right? Sometimes over the time of your development, it might affect your current GDP because of your past development. So it is very important to see how those past development impacting your current GDP growth. So it is important to see, and that is how we can do by autoregressive model. And finally we have VAR model or vector autoregressive model. Usually when our autoregressive model, we use in a univariate case. VAR is a multivariate case. I mean doing the same thing in the more than 2 or 3 variable case. If we are talking about 2 variables, instead of saying unemployment, let's say we are talking about inflation as well. So now we have 2 variables in our model and we have GDP growth, for instance, in this case our dependent variable. In that case we can use VAR model to understand how the past values of unemployment, inflation are causing effect on your GDP. So that is the VAR model, multivariate case. Autoregressive, on the other hand, is mostly univariate model where we can see one dependent variable and one independent variable and how their past values are affecting that particular case. So univariate, in the case usually we use autoregressive, simple autoregressive model. In a multivariate case we use VAR model. Now as I said, the univariate model, here it says the ARMA model, autoregressive moving average model, make the series stationary first, as I told you, by doing a unit root test, and then if in the case of multivariate model we can use VAR, vector autoregressive model, or and also co-integration model. So for multivariate case we can use VAR and co-integration. Univariate case we use moving average or autoregressive moving average or ARIMA model. So now what we have learned here, we learned that we start with the time series with the component analysis. There are 3 components, and then we go to check the stationarity problem. We can convert non-stationary data into stationary data, and then by using unit root, and then after that we need to see how we can remove and also doing our regression modeling by using univariate models, using this model, moving average model or ARIMA model or ARMA model, and the multivariate case we use VAR and co-integration model. So this is the theoretical part or understanding of time series analysis. Now let's move on to time series analysis using R model, and now we would like to see how these theory applications in the R. Now in this R studio I'm going to show you some basic analysis of decomposition of the trend, seasonality and cyclic variation from the time series analysis. So let's see how this happen. For instance, in this case I'm using R Markdown, and I strongly recommend you to use your typesetting or writing in R Markdown platform like this. R Markdown platform. R Markdown is a very interesting platform using R Studio, and then you can use GitHub to start the project. Through this GitHub you can upload your project into your GitHub account, and then you can share with publicly who are interested of your work. By putting the analysis and stuffs in the GitHub is a very good way to improve your profile as a data analyst. So do these things using the R Markdown platform and also the GitHub account for your analysis, record and typesetting. Now in my case we are using title called time series, and in this case let's assume that we are first understand how to create a time series in R. Upon already importing our data into R, where you can find here in this particular case we are using AR passengers data in the TS model or forecast package. You can do the forecast package, library forecast. Under the library forecast you will find the AR passenger data set already there in the R package. So this TS is this TS meaning that the time series, and you just simply TS is the command for your time series analysis in R. So it may be numeric or integer. So in this case you see TS input data frequency 4 here, start with the 1959 the second quarter frequency, quarterly data we are using. So this is how we can arrange our data set in the time series. Very easy for R platform. Now the next one is, as I told you, that you are having the problem called the trend and seasonality, and it has two-way additive and multiplication of the model. And in this case I'm showing you the both the things. For instance, in this case I'm using the what do you call it, the R platform to find out your yt is equal to st, tt and error term. Then we have multiplication, same thing, st multiplied by tt and et. These are all already explained, time, seasonality and error. So a multiplicative time series can be converted to additive by taking log of the time series. So only simply taking the log can converting your multiplicative time series into additive time series. Now the second part we are talking about is the how to extract the trend, seasonality and error term. Now in here we can see that the trend, seasonality and the decomposition of the time series analysis in R, we are using STL, this command, STL within bracket command. It splits the time series into seasonality, trend and error components. So my dear learners, here just remember STL, this within bracket command can split your time series into 3 different components. And by seeing here the euro stock data, it is also in that particular package. So you can upload the euro stock market data, because usually in time series we use the stock market data for our analysis, because it can also convert for forecasting. So we can decompose this by using the data that we are talking about, the data frame and what is the type because of the model that we're talking about, and then the plotting. Now you can see here the plot looks something like this, the decomposition of multiplicative series. So how the decomposition happening here, my dear learners, we can see here that in the downside you can see that this is the decomposition after decomposition, and this is the before decomposition. So this is the before and after decompositions of your time series analysis. Now we can also do the same thing. Two things are how to test your time series stationarity. So for checking your time series stationarity, I told you that there is a model, and this model call or this technique called augmented Dickey-Fuller test or unit root test. Okay, so you need to do the unit root test. So Dickey-Fuller test, augmented Dickey-Fuller test is very important to convert an ADF test. Within bracket is the command for that particular time and stationary conversion of your time series data set. So differentiating a time series means to subtract each data point in the series from its successor. So first differencing or second differencing, depending on how well you can smoothing your data set. It is commonly used to make a time series stationary. For most time series pattern, first or second differentiating is necessary to make it stationary series. So you have to convert your time series analysis by commanding ADF or augmented Dickey-Fuller test. Now, as I told you, this is the AR passenger data. AR passenger the data set that we were using under the forecast, and this is the seasonality differentiated. And after that, when we differentiated for the time stationary, when we take the stationary, it looks like this. The final outcome of the stationary data set, something looks like this, and this is the stationarity of the data set. So as we understand some of the concept of our theoretical underpinnings, and also we are demonstrating how we can use our theory using our platform, and of course using our Markdown, you can just simply knit it. And how can you knit it? Once you've done your analysis, just click knit, go to the HTML, click the knit for HTML, and simply the R Markdown will convert your analysis into HTML format. And you see how wonderful it looks like, right? The time series, what I have done so far, it is already converted into an HTML series. You can see what I have done is everything is there. So all you have to do, you just have to print your report and submit for any type of assignment or data analysis. R has a very interesting and good platform like R Markdown. You can use, you do not have to use any Word or LaTeX format to typesetting of your analysis. Inline coding using the R Markdown, you can do it very easily. And once you have done it, you can publish by simply publish the document into your GitHub or in RStudio publishing platform as well. So with that note, I think I tried to analyze your time series concept in very briefly in a short way, but in the next tutorial I am going to show how we use the same concept by eViews, Stata and Python. So until then, thank you for watching my tutorial, and if you like and if you think it is a valuable, please do subscribe and share with your friends to help me to help others. Thank you. Bye bye.